Hello friends, welcome to another refrigeration and HVAC mechanic red cell license exam reviewer. Today's topic is on the fan speed, static pressure, and power. So is the fan loss or fan affinity loss. To illustrate this, we have a problem here. The RPM of a 3 horsepower ducted fan moving 1200 CFM is increased from 900 RPM to 1800 RPM. If the initial static pressure is 0.08 inch water column, what is the resulting CFM, static pressure, and horsepower? So we see here that we've got a fan wherein the speed is doubled from 900 to 1800. So we have the given CFM1 is 1200 CFM, static pressure 1.08 inch water column, horsepower 1 is 3 horsepower. RPM 1, RPM 2 is increased from 900 to 1800 RPM, so speed is two times the initial speed. So the unknown is the following three values: CFM2, static pressure 2, and horsepower 2. So the solution, we use the fan loss. So for CFM, it's a direct proportion. If you increase the RPM2, if you double the RPM, or doubling the fan speed, you will also double the CFM, the volume flow rate of the fan. So in this example, CFM2 is equal to CFM1 times RPM2 divided by RPM1. So the ratio of the two RPMs, CFM2 is equal to 1200 times 1800 divided by 900. CFM2 is equal to 1200 times 2, and so we get 2400 CFM. So now we can conclude that when the fan speed RPM is doubled, the CFM is also doubled. Let's see what happens to the static pressure. Static pressure has a formula of static pressure 2 is equal to static pressure 1 times the square of the ratio of the RPMs. So in this case, we have static pressure 2 is equal to 0.08 times 1800 divided by 900 squared. So we got static pressure 2 is equal to 0.08 times 2 squared is equal to 0.08 times 4. Static pressure 2 is equal to 0.32 inch water column. So the conclusion is when the fan speed RPM is doubled, the static pressure is increased 4 times because 2 squared is 4. That's why the static pressure is increased 4 times. Now finally, let's see what happens to the horsepower or the power input to drive the fan. And so horsepower 2 is equal to horsepower 1 times the ratio of the RPMs cube. That's the fan law number 3. So we've got substituting the values. We've got horsepower 2 is equal to 3. That's the horsepower 1 times 1800 divided by 900 cube. Horsepower 2 is equal to 3 times 2 cube. Horsepower 2 then becomes 3 times 8. And horsepower 2 is equal to 24. So 24 is now 8 times the original horsepower of the motor that drives the fan. So the conclusion is when the fan speed RPM is doubled, the power needed to drive the fan is increased 8 times. So if the voltage is constant, that means the current draw, the amperage is also 8 times. So I hope you learned something out of this red seal example, and I'll see you again on the next video.